All right, folks, welcome to the Temporal Community Virtual Meetup Halloween Edition. My name is Lauren. I'll be your host for today. Scheduled today, brief community update, then talking about workflow update, interview with Spencer Judge on the SDK team. And then with whatever time we have remaining, I will run through some TypeScript samples. And before we get to the schedule, costumes. Anyone else have costumes or is it just me? Let's see if
I think it might just be you.
one. All right. Well, my partner made these uh temporal pumpkin temporal pumpkins, which I loved for the New York meetup. My favorite one is up at the top right, the heart eyes. So meetups, we now have some temporal user groups on meetup.com. One for New York, one for Seattle, and one for London. So if you're in that area and would like to get notified of our meetup events, join one of those. Then upcoming meetups, we were sponsoring and speaking at a joint Python NYC and PyData NYC meetup at MongoDB's office. Then we have a Chicago Java users group that we're speaking at. And then the next monthly virtual meetup will be same time and place, the last Tuesday of the month, 9 a.m. Pacific, same Zoom link. And then in December, we have a temporal meetup in Dallas. And if you're not on the community Slack yet, check it out at t.mp/Slack. And we also have a monthly newsletter. If you're not subscribed yet, that's t.mp/news, where we have product updates and resources. And I also post to Slack in the announcements channel every month with a TLDR of the newsletter. Here are some past meetups. So in October, we did one in Raleigh, Durham, Boston, Paris, London, New York. This is the London one with Max speaking, and then this is the New York one with Max speaking again. The New York one was at Datadog office with a nice view of Empire State and swag and far too much pizza and pie. So workflow update. I'd like to introduce Spencer Judge. He's a language runtime engineer at Temporal. And if you missed it earlier this year, at the May virtual meetup, we did a fireside chat with him. If you'd like to hear more about what he's doing and what it's like for him to work at Temporal. Brief history on Spencer, UW, and then six and a half years at what is it? Tableau,
Nailed
the
it.
data visualization company, and then a couple of years at a fintech startup, and then here, and he's been here since 2020, so like 3 years. And Spencer started out on the SDK team and built the Rust core SDK that is used by the TypeScript, Python, and .NET SDKs. And he also developed, I think, most of at least the SDK side of versioning. And what other big projects have you worked on or are you working on?
I think that covers kind of like the top line stuff. But yeah, I mean, like update, like we're going to talk about. I did the SDK side for a lot of that too.
Okay.
And a handful of different. I just did it in the Python one as well as in the core library itself too.
Okay, so added support for workflow update in core and also in Python.
Mm-hmm.
And then other folks will do the Lang side, the .NET side, and the TypeScript side.
Yeah, and all of those are like kind of wrapping up, so coming out soon.
Oh, nice. So I guess getting started, what is update, Spencer?
Yeah, good question. So, for those of you who already have at least some familiarity with Temporal, you probably know that we have like a couple concepts called signals and queries, right? So signals are a way for you to like send information to a workflow one way. Queries are a way for you to get information from a workflow one way. An update kind of lets you do both atomically, right? So like you might like to send some information and also get a response with some information about the state of the workflow in one RPC call. Um, Update lets you do that, right? So the idea is that you can define update handlers in your workflow code, just like you would define a handler for a signal or a query. But in this case, the handlers are allowed to both change things and return some response. Where signals can change things, but they can't return a response. Queries can't change things, but can return a response. So now you can do both. Um, Importantly, they also provide you with like a optional validation handler you can write that'll run before the main update handler, and that allows you to reject an update request without writing additional stuff into history. And this can be really valuable because like something you can potentially run into with signals is maybe some client is sending like signals that your workflow code can't understand to the workflow, and that's not really in your control. And that thing could end up filling up history with a bunch of signals you can't do anything about. Now you have a chance with update to like reject them and not affect your workflow's history, which is a pretty valuable feature for some more advanced use cases. So that's kind of like the top level overview of what update lets you do.
Okay. Um, let's
Oh, look at
take
that! I
a
already
brief.
jumped ahead of your bullet point.
We can take a brief look at the docs for update here. So it was released behind a flag, and it's still behind a flag, so not on by default in Temporal Server version 1.21. In the Go and Java, is it published yet on Python or just
Python is
released
not
command?
released with it yet. .NET, I think just yesterday, I'm pretty sure got released with it.
Oh,
Python and
nice.
TypeScript haven't had releases, but they probably will pretty soon.
Okay. Um, Update is synchronous blocking call that could replace both signal and query. Okay. So it says signal with the overhead and latency of a query. Um, so in terms of latency, a query, uh, I guess can you explain how uh, update achieves the latency of a query?
Yeah, sure. This bullet point, it's actually kind of interestingly worded because you could take it either way. You could take it to mean that query is either slower or faster. um, but query is typically probably going to be a little bit slower. And the reason that update is more like that is because signals don't have to reach one of your workers. They only have to reach the temporal server. So like you're delivering some information and the temporal server gets it, writes it down in the history, and then typically right away, but potentially at some point later, that is delivered to a worker to process in a task. Um, a query, since the workflow code needs to be like run at the state it's at right now in order for it to come up with a response, it needs to actually hit a worker, which means there's a little bit more round trip. Update sort of works the same way, but we're planning on like expanding it to kind of let you choose what latency characteristics you want. So like right now in kind of the experimental version we have right now, uh, there's synchronous update, which works a lot like query. Like it has to get down to a worker. The worker, does some stuff, either accept it, reject it, and the response comes back to the client. Um, but we're planning for there to be a total of sort of three modes for this. So there's that mode I just described. There's a mode where the client only waits for it to like get down to the worker, and then you can query the status of the update sometime later because updates are allowed to run for a very long time. You can do whatever arbitrary stuff in them you want, like start other activities or other temporal things. And then the last mode would be you just want to deliver it, and that would be kind of like Signal, where it's like as soon as we take the update, we're just going to write it down and deliver it to worker, and the client's not going to care about the response. So in this way, you can kind of pick which latency characteristic you want.
Okay, so in the second case, as soon as like the matching service matches the update task with a worker, it will reply back to the front end, which will reply back to the
Mm-hmm.
client.
Yeah,
Okay.
that's pretty much right. Yeah.
And then worker processes the task, responds back to matching or to the front end. And then what happens with the result once they get to the front end?
So that'll go to history where we're going to write down. It depends on what we replied with, right? So like maybe we've chosen to reject the update in the kind of like validator stage that I was talking about before. In that case, I don't know if it even goes to history at all. I think it just replies right through the front end and says, "Oops, rejected," and we're not going to write down anything because that's the point of that mechanism. But if you do accept it and you return a result, yeah, it's going to go to history. We're going to like write down the fact that it was accepted and like what the result was in history because that's important now because we have to, be able to replay it, and then we're going to kick back the result to the client.
Okay, so you're waiting for the write to disk before replying to the client.
Yeah, I believe that's true. It's a good question. We might kind of do both at the same time, but I'm like quite sure that we're going to go and write it down first before we'll roll up the reply because otherwise we could lie.
Right, right. We probably want to be guaranteeing that when we respond success from the result from the update that we've already persisted it.
Yeah, exactly.
Um, okay, so I guess, but the comparing the latency of a signal to query, a signal, you just hit the front end, it goes to history, saves it to the database, and then responds.
Hmm.
Query, it goes maybe straight to matching from front end, and then to a worker,
Yeah,
and then back.
yeah.
So, uh, is it possible, like if the worker is like hosted really close to the server, that the query would respond faster than the single write to the DB?
Yeah, I mean, it's definitely possible for sure. Like, especially if perhaps your database writes are like quite slow, um, then yeah, I think what you're saying could definitely happen.
Okay. And then update is sort of a combination of both, where it both takes time to go to the worker and takes time to write a single
Yeah,
time.
yeah. But like I said, there's going to be kind of more than one mode for you to choose from later on. So like right now, it's kind of more like the query way, but you'll have other options later.
Okay. I just realized I forgot to turn on my light.
Oh,
All right.
there we go. Are you sure you're not going to burn up now?
I should be like sparkling or burning and dying.
Yeah.
Um, uh, Mango, I don't know if you saw this, but I got the teeth you suggested. They're just very hard to mold correctly to your teeth so they don't fall out. So I got to work on that for next year. Um, let's see. So okay, uh, latency sort of at the moment a combination of both. Overhead in terms of non-latency would be like um, how many writes a disk or something.
Yeah. Yeah.
Okay.
So like that's the important bit about the validator portion is you can choose to have much less overhead than you like always will incur with a signal today. Like signal's always a write to the
Right.
database right now. Whereas this doesn't have to be if you reject it. Um, but if you accept it, yeah, like same deal. We're gonna make a write.
Okay. So you can opt out of both uh, latency of writing to the disk and the space that it takes up in history.
Mhm.
Okay. Let's see what else is in the docs. We've got an update handler, just like we have a signal handler. When there's a potential for multiple updates to cause a duplication problem, Temporal recommends adding item potency logic to your update handler that checks for duplicates. Okay, so is this implying that if I send an update from a client that two of them, like more than one of them, might be written to history in some edge?
No, I mean only one of them is ever going to get written to history for the same. You can give updates an ID, so there can only be like one update with one ID. The reason that this is in here though is that we guarantee for sort of all of our stuff like at least once execution for the most part. And the reason that could happen is like we could tell a worker to go do some work on a workflow um, it could start doing it and then like, you know, encounter a partition or whatever and fail to respond. And then we don't know anything about whether it happened or it didn't. And if all you're doing is like launching other stuff that has to go through the server, like normal activities or whatever, this probably isn't really a problem because like you have to successfully respond to that task before the activities start. That, that's kind of all
Right.
okay. But if you start like a local activity, which you can and is allowed, and might begin, performing some side effects, some doing something that's actually going to affect the external world right away, then yeah, that could potentially happen more than once for the reason I just said, where like worker gets a task, you know, kind of starts doing stuff with it, fails to respond. We think, okay, well, that didn't happen, so we're going to have to try the task again, and some other worker is potentially going to do the exact same thing.
Okay, so there's a risk of calling local activities multiple times. I feel like that's already a risk with local activities in general.
Yeah, any activity really, because even with real activities, this you can have the same task problem where like you start you schedule the activity, some worker picks up the task to do it, same deal, encounters some network issue, can't respond, and then we try and run the activity again somewhere else. So, kind of as a general rule, we always want um, activities to try to be idempotent.
Right. Um, but I guess like in the full activity case, if it's not idempotent, I could say max activities one or max attempts one, um, and make sure it's not uh, executed multiple times.
Mm-hmm.
I don't have that option with local activities,
No.
um, even when it's not responding to an update. So I'm wondering, are there any other update specific duplication issues?
Not that I think
Mm.
can think of. Yeah, I mean, like a lot of things, local activities have a lot of edge cases, so you should always be careful when you're using them. But if you're not using local activities at all, I think this gets a little bit easier to reason about.
Okay. So it's not a risk of multiple update records in history. It's just risk of multiple deliveries of the update to the worker and the update handler.
Yeah, for the most part. And but to be fair, like I was kind of specifically talking about this case where you're definitely sending updates like with the same ID that you gave them. If you're not doing that, say like, you have different clients sending sort of like the same update, but they don't have any way to like agree upon the same ID for like the same like logical update, then yeah, I mean, from our perspective, those are just different updates. But maybe from
Right.
your perspective, like you were trying to do just one of them or whatever. So that would be why it's important to try and use like an ID that is unique and makes sense.
So an update ID is like a item potency key or token.
Yeah, like yeah, it's just a way to uniquely say like this update has like this identity and don't let me do it twice from. So yes, in other words.
Okay. And when I'm using an SDK client to make an update, is by default is the ID set for me, sort of behind the scenes?
Yeah, like if you don't provide one, you just make up a UUID. Um, but yeah, you always have
Okay.
the option to explicitly set it.
So then if so the SDK generate the UUID and
Like
then
in this case,
make
it's
work.
actually the server that if you send, I mean, this doesn't really matter to a direct user, but that is like just if you set an empty string for the update ID, the server is going to turn it and the reason for that is that for the async update stuff that will exist later that I was making reference to earlier, the server needs to be the one who generates the ID so that it can give you back like a handle to it that you can use to pull on its status.
So that's curious to me because like I feel like um, the general recommendation for idempotency tokens is the client decides them and sends them. Uh,
Mm.
so so like in that case of the client deciding, if I send it and I don't get a response that it was and I just or I feel like a disconnect and then I retry, I'm sending the same key.
Yeah, right. You're right. Actually, I did say that kind of a crap. It definitely doesn't need to work that way. It's just we happen to provide it as like a convenient way for you to not if you don't care about this situation, you don't want to make up consistent IDs that you'll just be able to get one. But yeah, you're right. In that situation, you would be better off defining your own ID.
Providing.
Yeah.
Okay. So by default, um, the server's generating the ID, which means that if my client disconnects after it's delivered the update, but before it's gotten a response, it will resend it and get a sort of duplicate.
Hmm. Hmm.
Okay, got it. So it would help reduce the risk of duplication if I opt into providing an ID when I make the update.
Yep.
Okay. Uh, Update has forfeit as admission. So this is if there's like a limit of concurrent requests or requests per second, then I guess the front end knows those limits and will reject an update
Yep.
before it even gets to the validation handler. Um, Assuming it passes that, it becomes admitted, and then it goes to validation, which is if you provided a validator in your workflow definition, then it'll go to the worker. Assuming it passes that, um, I'm guessing, does it like respond to the server or does it immediately call the update handler?
It immediately calls the update handler.
Okay,
And only after that has come up with some status, then and that status might be the handler's not even done, right? Because the handler's allowed to wait on things from server, but it's guaranteed that like the semantics are we run the validator and then we immediately run the handler up until either
it
it
blocks
would block or return.
return.
Yeah.
Okay, or throw.
Yeah.
Um, Completion. The update handler can return result of platform sends the update outcome back to the original invoking entity. All right. So here it's talking about update accepted, and here update completed. Um, the current path is both of them will get written during the single reply from the worker.
Yeah, you can have update accept like if you were to block
Right, right. So
like I was
if you
talking
don't
about,
return,
then
right,
we could end up writing just accepted, and at some point later,
just
we'll
this
either
one.
write
Okay,
completed or failed.
got it. Um, cool. I also wanted to say if there's any questions from anyone tuned in, please feel free to either unmute and shout out or write a question in the chat,
Yeah,
and
happy to
we'll get to it.
answer.
Let's see. Next, let's look at signals and queries. So when would I? So it sort of sounded like update is a superset of signals and queries, but what cases in which would I? What are the cases in which I would want to use a signal over an update or a query over an update?
That's a really good question that I haven't thought a whole lot about. There's, I mean, there's one very sort of niche situation that we were talking about yesterday. If you reset workflows, signals will get applied to the kind of like new workflow that gets created as a result of resetting. So like information isn't lost. Um, Whether or not you care about that or that's even a desirable thing, or should you ever even use reset are all very debatable questions, but that is one case where you might care about that, right? Like you care about like the preservation of all the information that was sent to the workflow when you're resetting it. But honestly, other than that, like somewhat dubious use case, I I can't think of a whole lot of reasons. Like, if we had done it this way from the very start or whatever, I think there would probably just only be update and there wouldn't be signals and queries.
So if I to clarify, just if I remember correctly, when I reset a workflow execution, I wanted to create a new one that only goes up to this event ID, and I'm always going to have things before it that happened, whether those are signals or updates with a smaller event ID. But there's a option for signals to apply uh, all of the signals, even if they were past that event
Yeah,
ID.
yeah, that's right.
Um, and we don't have that option currently for update.
Yeah, currently, I think the idea is that it is going to end up that way, and like then
Okay.
it comes down to like all the kind of different options, right? Because like Right now, the whole like the tell the client right away when it was first admitted option doesn't exist. But if that exists, then the semantics from the client's perspective are basically exactly the same as signal. Um, and I think, I mean, this isn't decided yet, but I think the idea is probably you could have an option to say, okay, like come in there, write it down so it's in history, and that will end up getting preserved the same way as like signals do on resets. And then you have behavior that's like literally identical to signal as one of the options for how you send updates.
Okay. And then uh, updates are rejected from a closed workflow execution.
Yeah. Mhm.
Okay, so if I need to figure out the state of a workflow execution after it's closed, then I need to use it.
Yeah, that's a great point actually. Yeah.
Um,
And I don't know if that maybe that's something we'll also like allow later on. I mean, I can. It's very debatable because like all the input to the update no longer makes sense. Like you're not going to be able to like use it to change anything. So perhaps that's a good reason for queries to stay around.
okay. And then any reason why I should use signals? There's the reset. I guess there's a lower latency of getting an acknowledge, but that's just currently.
Mhm.
Um, it'll be the same once we get that version of update.
Yep,
Any other reasons for using signals?
I don't think so.
Okay. Is it like to support higher throughput because you don't need to go to the worker?
Well, same kind of deal where like once we have that like admitted stage thing, then it's exactly the same. You'll get the same behavior. But yeah, for right now, that's like sort of maybe true. And but if you're doing them with that kind of load, like it's pretty unusual because you're possibly getting into problems in for other reasons like filling up history too quickly or overloading your workers or whatever.
Okay. Next, let's look up how to use update, and I will try going through the Go sample and asking you questions, and you can correct me.
Sure.
And with that, so we're in temporal.io /samples go /update, and then here's the update file that imports workflow, and we can tell that this function is a workflow because it takes a workflow context and returns a tuple of integer and an error. We're setting a counter to 0. Then we're creating this update handler, and the name of it is fetch and add. And then here's the handler. So it's an anonymous function that takes the workflow context, the argument that was passed by the client. So in this case, just a single integer. Saves the counter in a temporary variable. So it's fetch and add. So we're fetching the value before we're adding. That's why we're saving it here. And then we add to the counter, and then we log, and then we return the original value and no error. And then so that was the third argument to set update handler. The fourth is the options. So workflow update handler options, and it gives us this validator non-negative. So before this update handler is called, we're going to call this non-negative validator. Gets the context, the single argument, and might return an error or nil. If the integer is negative, we log, we return an error, and then if it wasn't, then we return null.
Yep.
Okay, and then this part was weird for me, just as someone not used to reading Go code.
Yeah.
So it's if uh, if this error that we got from setting the update handler is not nil, then we return 0 in the error. So when would this thing return an error?
That's a great question actually. I think if you, for example, tried to register two handlers with the same name, that would probably turn an error there.
Okay. And then after we set up the handler, we are getting a signal channel to done, which is just that type of signal, that the string done. And we're receiving on that channel. What does the receive nil mean?
It
So
just means
like
you just don't care about the data in the signal. All you care
that
about
would
is
be
that you got a signal.
if I cared about the signal and I want to do something with it, this would be like an anonymous function.
No, that would be like a pointer to some
Oh,
variable that you're going to
value.
write the data into.
Okay. So the argument or arguments to the signal get written into there.
Hmm.
Okay. Like at arg. Whoa. Oh, I can't write in here. Um. Okay. So we're waiting for the first instance of the done signal, and we're doing nothing with it,
Yeah.
but we're unblocking. So this receive thing is blocking.
Yeah, exactly. All that's doing is just we're going to sit in the workflow until it gets that done signal, and then it's going to return immediately.
Okay. And then if we look at the rest of the code, we have the worker, which should just make a client, and then
Yeah, your standard boilerplate start a worker code.
register this update.counter. So that's the counter function we just looked at.
Yep.
And then starter main, we make a client, temporal client. We call client.execute workflow of the counter workflow. And then we start in a loop. We start calling update workflow with the workflow executions workflow ID, and then the update, and then the argument.
Yep.
So this, which update to call, and that's the argument of the update. And this is a handle to the update. And we're using this down here, handle.get. So this is getting the result of the update and putting it in here. Um, I feel like this is making me think of the second version of update that you mentioned.
Yeah.
Uh, is is this the second version, or is this the
Yeah,
guy
it's
expect?
not it's not actually this. You're right though. I mean, it looks like that, right? Like that's the way that you would use it when you're doing an asynchronous update. And I think I want to say that the Go SDK just only works this way because of reasons that I don't remember exactly. But in all of the, for example, three newer ones, Python.NET and TypeScript, you kind of have two choices here, right? You could either like execute workflow, which just does it all in one line, right? Like it sends the update and then it blocks waiting on the result, or you have start update, um, which looks like this, right? Where you like get a handle and then can call result on it to get the result later.
Okay.
But this one, even though it's broken apart into sort of two chunks, it's not actually using the like async mechanism behind the scenes right now. It's still doing it sort of the synchronous way.
So this does not talk to the server.
It I think it will in the sense that you could error on that line if like the workflow isn't found, you know. Um, but
Okay.
it might not at all actually. I didn't implement update and go, so I don't know off the
Okay.
top of my head. But yeah, it might just be set up that way for the to in anticipation of the async mode later. But it's not actually doing any network. I don't totally know. I'd have to go look.
Okay. So in the newer SDKs, there's like basically two methods. There's like a workflow handle dot uh, uh, execute update and start update.
Mm.
And then start update, you does start update start talking to the server or and return immediately, or once it's sent the request?
So they're both right now in the newer ones, even though they have the two methods, they're still both doing the same thing because the async mode doesn't actually exist.
Okay.
So
Okay.
in the newer ones, it does work the way you were suggesting, which is like the start call doesn't even like nothing even happens until you until you then go and like actually try and get well actually no that's not true. I lied. It does do stuff. You just won't know what happened until you try and get the result out. Um,
Okay.
but like whether you've called execute update or start update, like in terms of what happens between SDK and server, like it's exactly the same thing right now. But later on, when the async stuff is implemented, the start version might, depending on how quickly your update took, use this different like polling mechanism where it actually polls to eventually learn about the result. But right now, it's just a synchronous call either way.
Okay. All right. So we get the result once the worker returns the result to the server, which returns it to us. So by this time, by the end of this statement, we've got the result there. And after the loop, we signal the workflow with the done thing and no arguments. And then workflow execution.get. So we're waiting on the result of the workflow and putting in here and then logging it. Okay, let's try this out. So at first I just ran temporal server start dev and that did not work because by default update is disabled. So we need to do set the dynamic config value for frontend.enable workflow update workflow execution to true. And then we can look at the samples go. Here's the files we've got. Update go, start our worker. We can start the worker first. And then once the worker is running, we can run the starter. We start the workflow. We do the fetch and add update with 0. It succeeds. -1, it fails. And this is like printing out the error we got from the validator. And then it's all added together to 20.
Yep.
So there, update works.
Do you have the UI? It would be kind of, or even just use the CLI to query the history, because it'd be kind of cool to see how the rejected ones don't write anything to history.
So here's the completed workflow. And we can look at started.
Yeah, so you see that there's only 5 or however many it was actual update accepted, update completed events, even though you did more than that, and that's because the rejected ones aren't written to history at all, which is kind of like that's one of the really nice properties of update.
So we accepted with a payload of 0, and then we don't see and the next accepted is up here, payload of 2. So the -1 we don't see a event for.
Yeah.
And then at some point we get the signal, the done signal, and then it will return with 20. Cool. Let's see if there we go. So this is the timeline view with each of the fetch and adds, and then the signal received done at the end.
Yeah, it's kind of cool because you can kind of, if you squint a little bit, you can sort of see how there's roughly an even space between each of them, which is probably where the rejection was happening. But we don't see any event corresponding to it.
Makes sense. All right, so we looked at how to use update in Go. I'm curious if you could share what it was like to implement in the core SDK. What was involved in that process?
Yeah, that's a good question. I mean, to keep it brief, the basic idea of what needs to happen to implement a new feature like this that involves kind of writing stuff to history and as part of making changes to the state of workflows. The way it kind of works in all of our SDKs, Go, Java, or Core, with sort of different levels of formalization, is that there are these little like state machines that are implemented for each what we call like commands, which are the things that you can do from workflows. So like, starting activities, starting children, um, you know, updates, yada yada yada. All that stuff are like commands that the workflow sends back, or they're events that get written to the history from the outside. Like signal just comes in as an event, but they're all represented internally with these little state machines. And so, the kind of high level view of what you have to do to add something like this is you go make a state machine for that concept. So in this case, I made like a new one for updates. And what that state machine has to do is process either events or potentially some other kind of input. In the case of updates, we have this new mechanism called messages that I won't get too deep into, but like basically there's a way for information to make it to the worker that isn't part of history, and messages is kind of like a protocol for delivering those. So like a new update, because it hasn't been written to history yet, will come in as one of these messages. And then you have the state machine that processes either that, or if you're like replaying event history, maybe it's processing like an event from history that says we wrote an update. And then, doing stuff with your code if it needs to, if we're not replaying. So like maybe executing the handler, getting a response back from that, and then figuring out, what we need to send back or server or not. So, you've got this little engine that processes these various inputs and sort of decides either, okay, like, we need to run your code and like, actually it's already happened with these results, or we need to run your code for the first time and like get those results, propagate them back to server. So it kind of like does all that in coordination with other stuff going on in your workflow.
Okay, so the state machine is responding to two types of input. One is the result of a poll or some communication from the server, and then the other is some communication from Lang. So Lang is like in the Node SDK, Node is the Lang, and you're the core.
Mhm.
So you will have told Lang to do something like handle this, call this update handler. It'll do that and like call the JavaScript or TypeScript code,
Yeah.
and then reply back to you saying, okay, this was the result.
Yep.
So you're responding to uh, input from Lang and from server, and deciding whether to send something to the server or to tell Lang to do something with the workflow function.
Mm-hmm. Yeah.
Okay. Were there any parts or pieces of that were challenging that you had to like, I don't know, refactor or redo, or look into, uh, do some research to figure out what was the right thing?
Yeah. I feel like this one wasn't too bad considering that it's like actually a pretty substantial and nice new feature. I mean, the parts that were kind of like different that had to get added, like that whole messages concept I referred to, like it just is a new concept that didn't exist before. So, I had to put in some stuff in the code for kind of propagating those through the different layers of stuff that's going on. That was that was fairly reasonable. I think uh the thing that usually ends up making most features hard in SDK is like how does it interact with local activities, because they have all sorts of these weird, they can do all these weird things that nothing else can do. And that's usually the part that ends up soaking up some time. So like, I made sure to test updates running with local activities a good amount and make sure that weird things didn't happen if they did stuff. And that's kind of they're always like the little bit that causes problems. But I wouldn't say it was any worse than it usually is. So like that part, ate up a little bit of time, but it wasn't that bad. Update actually, I think um we had a nice time like make sure it was going to kind of integrate in a way that was reasonable, and I think that worked out fairly well.
Okay. So the SDK side of implementation wasn't too bad. I know that the server side took a long time. Do you have like a
Yeah.
sense of uh, the story of like when that started and what was involved there?
Yeah, I mean, I didn't work on that directly, so I have sort of less direct insight, but I know, a big part of it was we kind of wanted to do a bunch of these different things at once. Like, we wanted to have a way to reject stuff without writing it to history. Like that was important. We wanted to have these like be able to fulfill all these things, like some of which still aren't turned on that I made reference to earlier. And there's just like, I think there's just like a lot of conflicting, not conflicting, but requirements that like make make it difficult because they kind of pull you in different implementation directions. And I think that was something that was difficult about it, was finding a design that was going to be able to satisfy, like, well, we want it to be able to work this way and this way and this way and this way, and like, get all these different properties. And that just requires like, quite a bit of specialization in different places to actually hit all those targets. So I think that was a bit challenging.
Okay. Specialization in terms of like learning the different pieces of the different services in Temporal Server and
I
like
mean, that's true. I meant specialization in the sense that like the way the feature works has to have a lot of sort of specialized implementations because you want different properties out of different ways of using
oh,
it.
okay,
Yeah.
got it. Um, cool. Well, thank you so much to you for the Core SDK implementation and to Matt McShane and Alex Shin, I think were the
Yep.
main server side folks. I think Matt started early last year, maybe, or
Yeah. Yeah.
so it was a gigantic effort. So thank you so much to them. In terms of future plans, do you know? You talked about the two other types of update. Any other updates that will be coming to update?
I think yeah, those are the main ones. Is like having the async way so you can like send an update and pull on it if it takes a long time. And then having the like admitted path where it kind of acts just like a signal. Those are the big ones. I don't think there are any explicit plans beyond that I'm aware of.
So signals have signal with start. So like I can signal a workflow execution that might not exist and it'll get started. Are we going to add update with start?
Yeah, that's in the cards too, for sure.
And then I can right now we've been calling from a client to a workflow, but I can signal from one workflow to another. Will I be able to update from one workflow to another?
Um, I I don't know if we said basically I don't see why not. I mean, it makes good sense. I
Okay.
don't know where it is exactly on the like list of priorities, but yeah, I, it's a sensible thing to want to do.
And then I think we might be working on signals cross namespace. Is that right? Something cross namespace.
I don't know. You got me on that one.
All right. All right. So hopefully one day we can update cross namespace. Don't hold us to that.
Yeah.
I don't know what I'm talking about. Um, all right. Anything else we wanted? So I can update both the child or just any external workflow execution in the future. Anything else for update? I think that's it.
Cool.
Okay. Thanks so much, Spencer. I guess let's see if there are any questions. I haven't looked at the chat in a while. Um, Rob
Don't
says, I
see
feel
any
like
in the chat.
if you don't need a response, update doesn't give you anything over a signal. Okay, if you don't need a response and if you don't need to reject. Right.
Yeah, but doesn't give you anything over. Also doesn't mean is any worse, right? So I
Right.
think he wrote that back when we were first talking about like why would you ever need signal or query anymore? And the answer is like kind of not really anymore, especially after we finish the other modes.
Cool. Any other questions for Spencer? I'd also be curious if anyone has a use case for update that they're like implementing now or planning on implementing. So feel free to unmute and talk about that if you're up for it.
Hi, my name's Mabel. I'm kind of curious, like, do you guys have kind of like samples of using Temporal to navigate through a web UI? So kind of like the web UI calls the workflow to call different APIs and so forth. Does that
Yeah,
make
that's a
sense? Okay.
yes. That's and in fact that's one of the sort of like showcase use cases for update. But I don't know if we have like a sample that shows like the whole end to end kind of app like that yet. Do you know, Lauren?
I remember there was one in a replay keynote. So if you
Yeah.
look at the replay videos, which are I can type, I swear. I think this one with Preeti and Samara, there was a demo in this talk. And if we haven't open sourced that code, shoot me a DM and I'll make sure that it's open source and we can get you the link to it.
Yeah,
I'm
that would be perfect.
at Lauren on the community Slack.
Yeah, like the general idea is like the back end is Go, so I would use like the Go temporal library to create the little workflows and then call it in TypeScript. So I would use like both SDKs, right? In that
Mhm.
scenario.
Yeah, that's totally doable.
Okay, cool. Yeah, I'll DM you.
Yeah, we should yeah, what you're talking about is very much kind of like almost like the reason that we actually made this feature. So we should definitely take that keynote demo or whatever else and kind of make like a good like end-to-end example out of it. So thank you for that call out.
Yeah, that would be perfect.
And thanks, Rob. Yeah, posted in the chat the link to the replay demo with like a UI and stuff.
Okay, cool. So it is all there already. Great. Awesome.
Yeah. Any more questions for Spencer? Looks like we're almost at time, so I successfully avoided having to do my talk.
Nice.
Which
Did
is
it.
fine. It was just a filler talk because we didn't have another presenter. I'm always happy to like walk through TypeScript samples, and we'll do that whenever we have more time. But if you're tired of the samples or seeing my face, then please do let me know if you're interested in giving a talk about your how you use Temporal, or would like to be interviewed, whichever you prefer.
Great. Well, thanks, Lauren.
Yeah, thanks a lot. I will see y'all next month, the last Tuesday of November.